force between 2 point charges at rest. You know, it is Coulomb's inverse square law. It is directly proportional to the product of magnitude of charges and inversely proportional to the square of the distance between the charges. This is wrong because directly proportional to square of the distance is wrong. Inversely proportional to the product of magnitude of charges. No, it is directly proportional to the product of magnitude of charges. Directly proportional to sum of, no, it is not proportional to sum of the charges. It is proportional to product of the magnitude of charges. Then electric potential inside a spherical shell. We know that as we move from center to the surface of a shell, potential inside is a constant and it is maximum on the surface as well as inside. It is same inside as well as on the surface. Decreases as the distance as you move outside. So it is the same everywhere inside a charged spherical conducting shell. So electric potential inside a charged spherical shell is same everywhere inside, so remains constant with distance as we move from center of the shell to the surface. Whereas electric field inside is zero. This is zero and it is maximum on the surface. As you move outside, electric field decreases. A wire of resistivity rho and resistance R, length L, is cut into 4 equal parts. Resistivity of each piece is, resistance is directly proportional to length and inversely proportional to area. R is equal to rho L by A. Resistivity is the property of a material. It doesn't depend on length and area of cross section. Rho is independent of length and area of cross section. So if you cut it into 4 parts, resistivity does not change. So resistivity same as original value even if you cut it. And suppose if you are asked to find out what is resistance when the wire is cut into 4 equal parts, resistance is directly proportional to length. So R becomes R dash is R by 4. That is okay. Okay. Dimension of this formula is, so this is F is equal to EQ, and this is actually the equation for a force acting on a charged particle moving both in magnetic and electric fields. EQ represents the force on the charged particle due to electric field, and the remaining formula Q into V cross B represents the force acting on the charged particle due to magnetic field. However, these both quantities represent force. So you know that F equal to ma, m is m, acceleration is lt to the power minus 2. So that represents force, mlt to the power minus 2. Read the following 2 statements. Okay. Net magnetic flux through any closed surface enclosing a magnetic dipole is 0. Oh, yeah, we know that. If any closed surface encloses a magnetic dipole, then flux through the surface is 0. That is Gauss' law in magnetism. Because the number of magnetic field lines coming out of the pole and magnetic field will be equal to the number of magnetic field lines entering into the other pole. Exactly right. Because how many magnetic lines of force come out of the North Pole? Same number of magnetic lines of force will enter into the South Pole. So how many magnetic field lines come out of the surface? Same magnetic field lines will go into the surface. Net magnetic flux is 0 because net magnetic field lines crossing is 0. So both statements are correct, and second is the correct explanation for the first. Mathematical form of Faraday's law. So E is equal to minus d phi by dt. You know it. Change in magnetic flux linked with a coil induces an EMF in it. This is called electromagnetic induction. So rate of change of magnetic flux induces an EMF. Which component offers resistance to the flow of alternating current, which is independent of frequency of AC? So which offers resistance to the flow of alternating current, which is independent of frequency? That is pure resistor. The resistance of resistor has nothing to do with frequency of AC, whereas capacitive reactance is inversely proportional to frequency, and inductive reactance is directly proportional to frequency. We know this formula. So reactance of an inductor depends on frequency directly. Reactance of a capacitor inversely proportional to frequency, whereas resistance of a resistor is independent of frequency. So option C. Electromagnetic wave having the wavelength lesser than 400 nanometer. 400 nanometer is for visible. Say visible range is 400 to 700 or 750 nanometer. That is for visible. And we know the electromagnetic spectrum starting from gamma rays, X-rays, ultraviolet, visible, and infrared, microwaves, and radio waves. So this is the least wavelength gamma rays. Next, increasing wavelength X-rays, ultraviolet. So they are asking lesser than 400. 400 comes for visible. Lesser than 400 means these three. Among these three, X-rays is available here. So 400 to 700 nanometer comes for visible, and wavelength is increasing for IR, micro, radio. Least wavelength is gamma rays. Less than 400 means out of these three, gamma rays, X-rays, and ultraviolet, it is X-rays. Other three are not available, other two. When a ray of light travels from medium 1 to medium 2, the ratio of sine of the angle of incidence to the sine of angle of refraction is a constant. This is Snell's law. We know it. A plane wavefront is incident on a concave mirror. The reflected wavefront is. So when a plane wavefront is incident on a concave mirror, if this is the plane wavefront, the secondary wavelets from here will reach the mirror earlier. Secondary wavelets from here will reach the plane earlier. They get reflected from the mirror earlier, whereas these wavefronts will reach the mirror late, little bit late. So this will be reflected here, whereas this wavefront, secondary wavefront, will be reflected a little bit nearer because it will travel more distance since it is reflected earlier. This will also travel earlier. So if you combine this, you will get a spherical wavefront, and it will converge at the focus of the principal axis. So if plane waves or parallel rays are incident on a concave mirror, we know this part in the case of parallel rays, if they are incident on a concave mirror, after reflection, they meet at focus. Similarly, if plane wavefront is incident on a concave mirror, after reflection, you will get spherical wavefront. Finally, it will converge at focus. So it is spherical wavefront converging at focal point, option A. 11, option A. Yeah. Then, in the following graph, stopping potential is represented by the point. It is this one, C. You know this. So this is saturation current D. So it is C. Stopping potential, the minimum negative potential of the anode, at which photoelectric current becomes zero. Photoelectric current becomes zero here. Y-axis will be zero here. The minimum energy required to remove an electron from the ground state of an atom, that is ionization energy. If electron is, for example, in the ground state of hydrogen atom, minus 13.6 electron volt of energy is required to remove it completely out of the atom. So particle emitted during radioactive decay having positive charge, that is alpha particle, negative charge is electron, and neutral particle is gamma ray. Yes. The column 1 consists of materials, column 2 the list of dopants, okay. N-type semiconductor. N-type semiconductor is the obtained by doping intrinsic semiconductor with pentavalent impurity. So this first one is C. I'll write it here. But don't write anything on the question paper, please. This is only for study purpose. P-type semiconductor is obtained by doping pure semiconductor with the trivalent impurities, that is A. And intrinsic semiconductor is a pure semiconductor which is not doped. B, so it is CAB. Where is CAB? CAB. CAB. Yeah, CAB is here, option B. Okay. Yeah, fill in the blanks. An electric dipole in a uniform electric field experiences. So here is couple. Yes, this is couple. And magnetic field lines form closed loop. And peak value of AC is dash its RMS value. You know that RMS value is peak value by √2. So that means peak value is greater. So it is greater than its RMS value. Peak value is always highest. A ray of light is always dash to the wavefront. So you know that the ray of light should be normal to the wavefront. So perpendicular. And photoelectric effect can be explained by using quantum nature of light. Is there any quantum nature? Yeah, it is here. It is quantum nature of light. And Reflection, refraction, everything can be explained by wave nature, but photoelectric effect needs quantum nature of light. Yes. Thank you.